during those periods of active REM sleeping, many times you will short circuit everything involved. That your eyes are moving all over the place, okay? Those eye movements have been brought about by the fact that you're short circuiting all of these muscle relaxation moves.
What do you mean by short circuit?
By short circuit, I mean you, under normal circumstances, when you go to sleep, you should be relaxing your muscles, your respiratory rate, everything. Short circuiting, what I mean is, you're in the process of going through the early stages of sleep, through REM sleep so you can get to deeper sleep. And in that process, you start to relax everything, then everything kind of comes up and then goes back down. Because what you would see, and actually there is a figure in your book. What you see is that you have these cycles. These you're awake, you're going through REM sleep, you come into, these deeper stages of sleep, you come back out, we missed a REM cycle here, come back out over here, we've got a REM cycle. Okay, we've got a REM cycle. So that something is going on in you. Something is activating. Oh, there we go. Activating the REM cells on, okay, or the REM cells off. Signals are coming, and they have to do with those orexin pathways. Signals come on down, they help you to regulate what's going on with all of that. So it's interesting, it's exciting, it's bizarre and confusing. If you ever want to do something wild, go have an EEG done. They kind of hook your head up to, it is kind of fun. Wires and when I had mine done, the clinicians that, it's a dark room, they want you to relax. I said, I'm going to go to sleep. You're sitting me back in this chair, it's the end of a long day, I'm going to be done. And she goes, oh, don't worry, you can fall asleep. We'd love to see what your brain waves look like when you're asleep. And then the next thing I know, there are these flashing lights and things. And my study was over. And she said, usually when I tell somebody they can go to sleep, they're still awake by the time I get back to the computer. You told me I could go to sleep, you put me in a comfy chair, turned on the lights, man, I'm going. And I went bang out. And so I found that I have very normal brain waves. So, for whatever that's worth.
How many years ago?
This was earlier in the year I had this done, yeah. So my brain waves are normal. My brain, on the other hand, is not. So yeah, the chemistry is all goofed up. And I have some cells that appear to be dying. So if you don't see me, you'll know that my brain quit. Yeah. I'm not too concerned about it. I don't think that's going to happen. But we all have problems. So this is obnoxiously complicated. This really is, and I want you to think about that vascular supply. We have this REM center sitting here. We've got respiratory and cardiovascular centers sitting here. We've got, oh, look at this signaling pathway. What do you think this signaling pathway is part of? The reticular formation. Okay? Yes, good old reticular formation. Reticular formation is obnoxious. It's involved with so much stuff. Here are the respiratory centers. Okay? Don't stress too much of this right now. Nucleus solitarius obviously is really important. Here we have 2 and 3. 1, 2, 3. Major components of the respiratory center. inspiratory, expiratory muscles, phrenic nerve to the diaphragm. You remember with these two sets of muscles, with inspiration, your rib cage lifts and expands. With expiration, exhaling, your rib cage contracts and is pulled down. The diaphragm on inspiration descends. So this leads to contraction of the diaphragm. As the inspiratory muscles contract, they lift the rib cage. So there's a lot going on. Your rib cage lifts and expands as the diaphragm descends, increasing the whole volume of the thoracic cavity, which will then put a negative pressure on your lungs and allow air to come in. So it's really kind of neat. Yeah, nucleus solitarius. That was one of those nuclei I said, please pay attention to. So I want you to just remember to go back and those slides are up already. But I put them up right after class the other day. So these, I think these are there too. I think they are. Has anybody looked?
Yeah. I saw 14.
Yeah, I think this is all there. Okay. Well, so when it comes to sleep, there are some abnormal conditions. And we're going to probably spend too much time talking about abnormalities. But when it comes to, and I want you to pay attention to something in here. I want you to pay attention to the hook, to the hook, to the hook. It's in there. It's here. It's here. Reticular activating system. All of these can have components involving that. Alertness. Alertness involves the brain stem, the diencephalon, which is your thalamus, hypothalamus, and epithalamus, and your cortex. Attention, frontoparietal association cortex. Its area, there are association cortices in this part of the brain. Frontoparietal. Parietal area has to do with sensory association areas. Frontal has to do with memory and management and eye fields. Those eye fields once again. And awareness. Personal experience. What the heck is, you notice I put in quotes. What is personal experience? That's an interesting question, isn't it? So, what's personal experience? Wouldn't that be a good question on an exam? What? Philosophical? No. No, personal experience is actually, we can talk about it at a biological level. So, give me an example of a personal experience. Yes?
Does it do with the pathways that we use?
Okay, I can go for that. But I was going to give you a simple one.
Being sick.
No.
Pain.
No. Yes. Red. Is red a personal experience?
Yeah.
Why? Because you learned what red is. If you have no experience with red, is there any chance I can actually explain red to you? Oh, there probably could be. You know? Like, red is like a strawberry. Or blood. Oh, no. Yeah. Personal experience involves what your sensory modalities have detected. Therefore, pain is a wonderful personal experience. Vision, personal experience. Temperature, personal experience. Combining those, personal experience. So what you're doing is you have a sensory event that you then store as a memory. Without memory, personal experience is gone. Darn. So your awareness of your surroundings is due to personal experience. You know you're in a classroom only because of personal experience. Yeah, no, I mean really. You really, it's very, very biological. So I'm staying away from the philosophy because philosophically, I don't know, you might be envisioning that you're in hell right now. I don't know. So, but yeah. So all of these together give you what we call your consciousness. You're alert. If you're not alert, you're probably unconscious. You're attentive. All right, cool. Attentive means your association areas are active. Because to be attentive, you're collecting sensory information and associating it. You're tying it together. And you're aware. You may recall other experiences that use the same association cortices, the same somatosensation or special sensory inputs, whatever. And between all of those, you have some level of consciousness. So consciousness in a philosophy class is very different from consciousness in a biological sense. So we're going to go through these various scenarios. Some of them are easy to understand, some of them are complicated, some of them bring in other issues, and hopefully we'll be able to talk about them. So, brain dead. Well, if you are brain dead, you only have spinal reflexes. You might have some lower brain stem function, but in general, from the neck up, if we were to look for electrical activity, we would see none. So you're missing functionality. Someone who is brain dead, however, if you put them on a respirator, hook them up to a glucose drip, they might live forever. You can keep someone brain dead alive for quite a while. This kind of brain dead. How do we get somebody who's brain dead? How do we kill somebody and get them brain dead? Drowning? Oh. That usually is like dead.
No, there was an actor, he kind of like an accident and he drowned. So that it wasn't drowned, he got amoeba going to his brain. It's kind of like, yeah, like, and then.
I love those amoeba, by the way. Those are so cool.
And then they tried to keep him alive.
Yeah.
Yeah, for a while,
But the amoeba ate his brain. Have you heard about those? You catch them swimming in Louisiana or something. So don't go swimming. Yeah.
What about, I heard this story about this girl who had her tonsils out and she's declared brain dead, but the family still has her hooked up to ventilators and stuff.
Yeah.
And she was like 6 or 7 years old.
Yeah. Usually brain death, and yeah, both of those can be a case of brain death. Typically brain death is when the brain in toto has been deprived of oxygen. That is the quickest way to achieve brain death. So occluding both carotid arteries can lead to brain death. Oh, wait a minute. I can choke you.